Welcome, viewers of this program. Um, the purpose of this presentation is to unpack a paper that was set by the South African Mathematics Foundation in the year 2023 for the juniors. This competition deals with juniors and seniors. Juniors are from grades 8 and 9, and the seniors are from 10 to 12. And there are two types of competitions. One is an individual, and the other is team. So this particular one is 2023 Junior Individual, and we will try to unpack it. It's part of a series of lectures that we are giving on different mathematics competitions which are hosted by the South African Mathematics Foundation. Amongst them are the Olympiad papers, and there too we will be doing the papers that are set at the junior and the senior level, rounds 2 and 3, from 2023 to 2025. So with that brief introduction, we will go straight into the purpose of this program. Okay, so let's have a look at the very first question that is set here. The factorial, I think you are quite aware of the factorial. It is the product of all the numbers from 1 to n. So when you speak about n is a whole positive integer, and the products of all the numbers from 1 to n is given as n factorial. So you'll have the 2 factorial is 1 times 2, 3 factorial is 1 times 2 times 3, 4 factorial is actually 4 times 3 factorial, which is 24, and 5 factorial will be 5 times 4 factorial, 120, and so on. Okay, now we are asked to calculate this quantity 11 factorial minus 10 factorial over 9 factorial. Now obviously, if we work out this number here, it's a huge number. As you can see, at 5 factorial is 120. And I think at 10 factorial, it's like 3,622,880 or something like that. So this is too big, but we can simplify this. Bear in mind what I said, 5 factorial is 5 times 4 factorial. So in the same way, 11 factorial is 11 times 10 times 9 times 8 and so on. And that is precisely by definition 10 factorial. So I'm going to take out the 10 factorial there for the simple reason that then I have the 10 factorial is now a common factor of these two terms. 10 factorial goes into this 11 times and it goes into this 1 time. So 11 minus 1 is 10. Now this 10 factorial is really 10 times 9 factorial into 11 minus 1. And this is all these are all multiplied, so you can cancel. The idea in bringing 9 factorial is to allow it to cancel like this. So you have 10 times 10, which is 100. Okay, so that's the answer to this problem. So as you can see, I write down the solutions as well in the typed form, pre-prepared solutions. And sometimes I can check to see whether my answer is correct. Okay, so as you can see, the answer here is given as 100, 100, and it is the same answer that I got. Let's go on to question 2. It is said that if you fold a paper 7 times, You can only fold a piece of paper 7 times. Okay, so Kolekha folds a sheet of paper in half. Okay, one fold. Is a half, and then she makes a hole right through the paper. Okay, she folds the paper in half and repeats this 6 more times. Now, I just want to see when she makes a hole through the folded paper, in one fold, there are 2 holes. If you make 2 folds, okay, so I can't draw the picture, but you do 2 holes, then you can imagine there will be 4 sheets. So when you make a hole, it will, so if you fold it and make this one hole and open it up again, you'll see 2 holes there. Okay, so if you fold it 2 times, 2 folds, then, and if you open it up, you can see you're going to have 4 holes. With 3 folds is doubles. Each time you got eight holes, which is 2 cubed, and this is 2 squared. All right, so you can see that the number of holes is actually depends on the number of folds. So here she does this and repeats this 6 more times. Right. In other words, she makes 7 folds. And you want to know how many holes there are. And as we saw, there's a pattern. It's 2 to the power of 7 holes. And that is 128. Okay, that's the number of holes in the single piece of paper. So you can imagine it takes you can't fold it too much. Even the sizes also become half the original size. So this will be very, very small in size. Okay, so let's get on just check to see whether this is the answer that we have. Yeah, so you can see at the end you got 2 to the power of 7, which is 128. So next question, m is odd and n is even. Which of the following is differently an even number? So you've got an odd number, so it's we have to know what what happens when you multiply and add odd numbers and even numbers. The basic thing here is that an odd plus odd, then you have odd plus even, and then you also have even plus odd. And odd plus odd is even. 7 plus 7 is 14, which is even. It works for all odd. But if you take an odd number and an even number, then the answer is odd. 7 plus 4, 6 plus 9, and so on. If you check it out, you'll see you'll always have an odd number. Oh, this is even plus even. Sorry. But if you add an even number to an even number, well, that's quite obvious. Right? You're going to get an even number. And also, if you multiply and divide, so if you multiply 2 odd numbers, you're going to get odd. If you multiply the odd and even number, you're going to get even. Because even is a multiple of 2. So odd times the even, right, the whole product will again be a multiple of 2. And here, if you multiply two even numbers, you're going to get even. In fact, here you'll have a multiple of 4 because you've got 2 here and 2 here. This is multiplication. Okay, bearing all that in mind, m is odd. So this is odd, and this is even, and you got odd plus even, so this is odd. Now odd multiplied by itself 4 times remains odd. And here you got an odd here, and this is even. So odd times an even is even. So once again, you have the same thing. And here you have an even times an odd, so that's even plus even. So that's even. And here you have m squared is odd squared, odd times odd is odd, minus, and even times even is even. And odd minus even will be odd again. And so this is even, it's odd. And here you have odd, even, and again you have odd here. So the question is, which of these is definitely an even number? And this is the only one, C. Okay, so let's get on to the next problem. So you can see right at the bottom, it says that only C is even. Now question 4, consider a 2023 digit number with all its digits equal to 3. So you've got a very, very large number. It's got 2023 digits. And all the numbers are equal to 3, right? So what is the remainder if the number is divided by 9? Now here's an important fact. If you divide a number by 9, say we'll take a few examples. 217, 36, 9, 4, 1, 2, and 7, 7, 1. If you divide this by 9, we want to work out the remainder. You'll see the remainder is dividing by 9. Right, 9 goes into this 24 and the remainder is 1. Here the remainder is 0. I'm going to do it very quickly. Here the remainder is 7. Right here the remainder is 6. Right. You can work it out and you can see that this is what you get. But there is a very quick way of getting the remainder. Here if you add digits, 2 plus 1 plus 7 is 10, 18, 7, 15. Right? You add the digits, and now you divide by 9. Divide the sum by 9. What's the remainder? When you divide 10 by 9, the remainder is 1. And here 9 goes into this exactly. So the remainder is 0. Here the remainder is 7. 9 goes into 15 one time, 6. 1076. The same thing. So in other words, what you do is to find the remainder. The quick way of doing it is add all the numbers, add digits, and then find the remainder. You might have to repeat this a couple of times. Because when you add, if the answer is 22, for instance, then you have to add that again, right? And then you'll find the remainder. Okay, So bearing that in mind, you've got this large, very large number, and you want to divide this by 9. So you add up all the digits. You got 2023 2023 threes. So add, you get 2023 threes. So you will get 6069. Sorry. So this sum is 6069. And now you have to divide. Yeah, now you have to divide this by 9 and find what the remainder is. But you can do the same thing, repeat this thing, and you'll get 21. 6 plus 9, divide by 9, the remainder is 3. Yeah, so that's the answer. So although you got a huge number here, you can still say what the remainder is when you divide by 9. The whole thing simplifies to a very simple calculation. Okay. If you want to know why this thing works, I'm just going to quickly tell you. You see, if you have a number, say if you have a number like A, B, C, D, this is a 4-digit number. This is actually equal to 1000A plus 100B plus 10C plus D, right? That's the place value thing. 1000A is actually, we're going to make it 999A plus A, and this is 99B plus B, and this is 9C plus C, and here you have just D. And here you see you've got a multiple of 9 plus AB plus A plus B plus C. So it's 9 times some number, a multiple of 9, right? 9 goes into the whole lot, plus A plus B plus C. So if you want to find the remainder, you divide this by 9, and then you'll have a new multiple of 9, and then you get a new remainder. So that is why you add A plus B plus C, you see. So that's plus D, sorry, plus D as well. So you add the digits, and that will give you a multiple of 9 plus that sum. Okay, that's a very quick description of that. Let's just check to see. You can see at the end here, you got the answer is 3. So let's go to the next question. Consider 4 teams, A, B, C, D. Each plays 1 match against every other team. There are no draws, and the teams A, B, and C have the same number of wins. If team A beats team D, how many wins does team D have? Now, it looks very, very complicated, but let's just try to draw a diagram. Okay, let's draw a table. We've got we'll draw a table of the wins and losses. You've got 4 teams. Okay, so you've got these teams play with each other, against each other. Let's put down A, B, C, D. Those are the teams. and we will record their wins or losses in this. Now, A can't play A, obviously, so this can be eliminated. The same with B. So there's nothing here in these squares. Right, so in the other ones, we can put a win, we'll put W, or a loss, or a win, or whatever. Okay, so when A plays B, if A wins, then here I've got when B plays A, then this would be a loss because A beat B, so therefore B lost to A. So every time you have a W, you'll have an L. And each time you have an L, A plays C, and if that's a loss, then as far as C is concerned, this is a win. So you'll notice I've got 3, 6, 12 squares to fill. I just took an example here. Let me just take that out. So I've got 12 squares to fill. And now there are no draws. So what does this mean? It means that the 12 empty squares have either a win, either W or L, right? So also the number of W's is the same as the number of L's. So each time you have a W, you have an L equals number of L's. Number of wins is the same as the number of losses. So therefore, there should be 6 L's. Yeah, so therefore there are 6 L's. Or six wins rather. It's the same thing. But I need to write down the wins, the 6 wins altogether. Now, where the W's are scattered, this we really don't know. But every time there's a W at a certain place, there is an L in the corresponding place. Yeah, right? So, when I say corresponding, I mean the flicking around A versus C, C versus A. Okay, there are 6 wins. Now they say that A, B, and C have the same number of wins. So you got these 3 teams, so they got the same number of wins. So how many, what is that number? Same number of wins. So if that number is 1, that means A has got 1 win, B has got 1 win, C has got 1 win. So there are 3 wins, and that's not right. Okay, so therefore there are 6 wins altogether. So this number will have to be 2. So each of A, B, and C had 2 wins. Okay. Now you do know that A beat D. So here I would have a W at that spot there, and I would have a loss here. So the question is, how many wins does D have? So D will have at least 1 loss, right? But there could be no wins here because you see each of A, B, C had 2 wins and there are 6 wins altogether, and all the wins are here. See, all the wins, the 2 here, 2 here, 2 here. All right. So there's no wins left to put down in the last column. So therefore, here you will have to have only losses, right? So D has got zero wins because D will only sustain losses. So D lost all and D won none. Okay, it's a very logical problem. But the important thing here is that when you draw a diagram, you will see how many squares there are. There are 12 games played. Are there 12? I think there are six. Yeah, six games played. No, 12. 12 games played. And there are so many results. All right. So let's get on to the next one. So you can see at the last line here, D won none. And there is a whole argument there. I'm recording this, so you'll have a chance to have a look at that. You can freeze it and read it slowly. Okay, let's get on to the next problem. We go to question 6. It says 3 athletes A, B, and C race one another over a distance of 100 meters. Okay, let's draw a diagram of that. So they race one another, A, B, and C. The running speed of each remains the same for the entire race. When A is at the finishing line, so A is here, which means that A has run 100 meters. Because the distance here is said 100. So when A is here, B is 25 meters behind him. So B is here somewhere. And the distance from there to there is 25. Now when B reaches the finishing line, let's see what happens there. So when B reaches the finishing line, C is 20 meters behind him. All right, so A came first, B came second, and C came third, and this is 20 meters. Right. When A was at the finishing line, how far behind was C? So obviously C would have been somewhere here. And the question is, how far behind? In other words, what is this distance here? So this is 25. So if I know this distance from B to C, then I can say how far C was. All I have to do is to add 25 and that. Right. Now the question is, how far is B behind, C behind? How far behind B is C in this scenario here? Okay, now obviously we have to learn something from this. So when B does 100 meters, when B covers 100 meters, C covers 80 meters, right? Because he's 20 meters ahead. So in other words, C's speed okay, you really don't have to do that. So it's a proportion problem. So you have that B is to C is 100 is to 80. This is as far as speeds are concerned. And then, So you want to know when B is covering 80, because at this point here, oh, I'm sorry, it's 75. So you want to know when B is 75, when B covers 75 meters, what is C? All right. So you can see the ratio here is 5. No, actually it's 75 here. Sorry. When B covers 100, C covers 80. Now that's correct. So C's speed is 4/5 of B. Let's look at it that way. C's speed is 80 over 100, which is 4/5 of B. So when B covers 80, we want to know about this here. When B covers 80, C covers 4/5 of 80. So that is 5 goes into 80 16 times. 16 times 4 is 64. So in other words, C has done 64. But this whole thing here is, yeah, he would have been at 64. So how far was he behind A? A had covered 100. So when A has covered 100, C covers 64. So C would have been 36 meters behind A. 100 minus 64. Oh, 64 meters behind 36 meters when A is the finishing line. All right. This is not 64. This is 80. That is 64. Because you want to know where he is when A is at 100. All right. So that takes care of this problem. Let's check to see whether our ah, B covers 75 meters. Oh, I see. Sorry, the diagram was wrong. You see, when A was at the finishing line, B is 25 meters behind him. I was saying 20. Sorry about that. Okay, so B was 75 meters, uh, 25 meters behind, but the his speed is still 4/5 of that. So he would have, when B covers 75, then 4/5 of 75 is 60. 5 goes in 75 15 times. And so that's 60. So the answer here is actually C would have been 60 meters and the answer is 40. All right. So sorry about that. That you can just correct that. Just as well I got these the actual solutions, so I can check to see whether my answer was right or wrong. Okay, there I made a mistake that I was thinking that he had covered 80. If B was at 80 meters, then he was in fact at 75 meters. So one has to read the question carefully. Sorry about this. Question 7. The minute hand happens to be precisely on top of the hour hand at midnight on a traditional analog clock. Okay, so this problem is about clocks. So all right, so at midnight, the minute hand and the hour hand are at the same place. Okay, that we know. So what do they say? Assuming the clock is running normally, what was the angle in degrees between the two hands 2 hours and 20 minutes past midnight? Now, 2 hours and 20 minutes past midnight is the same as saying it's 20 past 2 in the morning. At 20 minutes, it's 20 past 2 morning. So we can have an idea as to what the minute hand and hour hand look like. 20 past 2, so you've got 12, you've got 1, 2, 3 here somewhere. So the hour hand is at 20 past 2, so it's slightly down there somewhere. And the minute hand, oh yes, is 4. The minute hand is exactly here. It's a longer hand, and you want to know what is theta, the angle between the two hands. Okay, let me write this down clearly. Let me use some other symbol. Okay, this is the angle that we're looking for. All right, now, how do we do this? Do we know any angles here at all? This is like a geometry problem. Well, for one thing, this hour hand is exactly at 4 at 20 past 2. So let me draw a vertical line. Through 12. Like that. Then you know this angle. This angle here is 120. Right? Because what's the reason for that is you got 4 out of 12. So it has traveled 1/3 a revolution. And 1/3 of a revolution is 120 degrees. So there's 120 degrees here. When it comes to 8, there's another 120. And when it comes to 12, there's another 120. So this entire angle here is 120. Just remember, between the top red and the bottom one. Now, we'd like to calculate what this angle here is. Now, it's not exactly at 2. Because when the hour hand moves, when the minute hand moves, this thing crawls its way from 2 to 3. Right? So it has moved a little bit because this thing has moved 1/3 of the revolution. You see, when the minute hand has to cover all 60 minutes for the hour hand to cover only 5 minutes. Like for instance, at 1 o'clock, the minute hand has just traveled through 5 minutes, but at 1 o'clock, the hour hand has traveled to 5 minutes. but the minute hand has traveled through 60 minutes. So the minute hand travels 12 times faster. The minute hand travels 12 times faster than the hour hand. We'll call it hour hand, HH. Okay? Minute hand, MH. So in other words, when the minute hand travels through 120 degrees, covers 120 degrees. The hour hand covers 10 degrees, right? So it was at 2 originally, which was 1/6. So this angle here is at 2, you've got 1/6 of a revolution because 12 is one revolution, 2 is 1/6. This angle here would have been 60 degrees. And now this hour hand has moved through another 10 degrees. So that's 70. So this angle here, that angle is 60 plus 10, which is 70. Okay, and you know the entire thing is 120. So if you call this angle here theta, that's a symbol which you normally use for an angle. Theta is equal to 120 because it's the whole thing minus 70. Because in both cases, I want to see how far has it moved from the vertical. So the answer is 50 degrees. Okay, I think this is the correct answer, if I remember. Okay, so there it is. You got almost the same. And the answer is 50 degrees. You see at the right at the end, you see here. All right, so let's get on to the next problem. We are now at problem number 8. Now, it says here the 3 standard fair dice are stacked neatly. Okay, you can see there's a picture here that you got a dice, 3 dice are stacked one on top of the other. The top number is 5. Right at the top, the number is 5. The question is, what is the sum of the numbers that cannot be seen from above or from any side? Okay, there are 2 numbers here between these two. I can see all the numbers around here. Likewise, I can see all the numbers around. I can see 5 numbers here. There's only 1 number that I can't see. And that's the bottom of this. Now, the opposite sides of a die, they all add up to 7 always. I hope you know that. The opposite numbers of a die, this is a fact. Go and try it out. You can take a die, and you will see that the opposite numbers sum to 7. So the 5 and the 2 are opposite each other, and 4 and 3 are opposite each other. And the 1 and the 6 opposite each other. That takes care of the 6 numbers. Okay, so it means that the number here, which we can't see, the first number you can't see, is 2. Right. Now, at the top of this, there is a number that I can't see. Let's call it A. And at the bottom of this, it'll be 7 minus A. Because the top of the middle one plus the bottom of the middle one, they add up to 7. So that's 7 minus A. And likewise, the top, the bottom of this, if you call that B, you can't see the bottom here as well. That'll be 7 minus B. Now, this 7 minus A is the bottom of the middle one, and this is the top of the bottom. That doesn't sound very nice. Anyway, so B is at the top here, and 7 minus B would be at the bottom. The question is, what is the sum of the numbers that cannot be seen from any side? So there are 5 numbers which cannot be seen. There's 1 number from here, 2 here, and 2 here. And I've written down what these 5 numbers are, right? And what is the sum of all this? So the sum that we are looking for is 2 plus A plus 7 minus A plus B plus 7 minus B. So those are the 5 numbers. And you want to know what the sum of it is. You got A and minus A cancel, B and minus B cancel. That's very nice. So you have 7 plus 7 plus 2, which is 16. So that's the answer to this problem. All you need to know here is that the opposite numbers on a die, they add up to 7. Okay, so let's just expose. And you see, quite right, the answer is 16. Okay, so let's just get on to the next problem. We now go to question 9. It says here that when 117 is divided by a natural number n, there is a remainder of 15. So when you divide 117 by n, the remainder is 15. Right. Now, the first thing we notice is that, note that n is greater than 15. Now, whenever we perform a division sum, your remainder must be smaller than your divisor, what you're dividing by. So this n is greater than 15. It cannot even equal to 15. If it's equal to 15, then the remainder will be 0. All right. So what is the sum of the possible values of n? Okay, so the remainder is 15. Therefore, n is a factor of, so you have to remove 15 from 117, and that will be a multiple. Because when you go to this, you'll see n times this is that one. So this will be the last possible multiple of n. That is 102. So n is a factor of 102. N is greater than 15. So what are the factors of 102 which are greater than 15? What is 172? 102 is 2 times 51. And that's 2 times 51 is 5 plus 1 is 6. So 3 goes to this. So what are the factors which are bigger than 15? Well, certainly not 2 or 3, but 17 is one of them. And then the other products are 2 times 17, 3 times 17, and 102, which is 6 times 17. So these are the possible values of n. Right. There are factors of 102 which are bigger than 15. Now, they wanted to know what the sum is. The sum. So you got 17 plus 34 is 51. 51 plus 51 is 102. So the answer I get is 204. Right? So let's just check that. Yes, the sum is 204.